unit today, new chapter on the sine law. Well, actually, this whole unit is on trigonometry of triangles, non-right angle triangles. So that's what chapter 7 was about. Is about right angle triangles, trigonometry. Get familiar with trig ratios. But unfortunately, not everything in life comes in right angle triangles. Okay, so I just want to start the class by posing this problem. Here we have a triangle. We're given two angles, 45 and 60, one length of 30. And we want to know what the length of A is. How would you go about solving this? If you didn't know the sine law already. How would we go about solving for this? Kenna?
What if you put a straight line from the top?
Oh, so we did sort of pick up something from the last box, right? So unfortunately, it's not as easy as, what we're going to say is, well, we have 45 degrees, the opposite side is A, the adjacent side is 30, I can do tan of 45, right? We can't do that because it's not a right angle triangle. This makes our life a lot more complicated. So what we'll do is what we did last time, what Kenneth just suggested. My orientation is off. So I hope everybody's got this triangle drawn. So you draw a straight line from the vertices straight down. So they've got two right angle triangles. A little bit. Okay, so we got something like that. Okay. So we'll just call this side the favorite letter X. So what this does is this splits our sort of problem into two, right? Now we're dealing with two right angle triangles that we're familiar with. So like we did last class, we're going to have a red triangle. And a green triangle. So what can we say about the red triangle? What can we say about the red triangle? Another right angle triangle, so hopefully drawing back to the information from the last chapter. What's the relationships that we have there? Anyone? Look at the red triangle. What's the relationship we have there? We have one angle, one side, and another unknown side. What is it that we have there? Tangent? Tangent? Well, tangent, if this is 45, this is the opposite. Well, where's the hypotenuse of this triangle? Yeah, right? So we look at our right angle. The opposite side is our hypotenuse, right? This is really our opposite side, and this is our adjacent side. So what's the relationship that we have there? Let me see. Do we not do our homework? Don't make me check your homework.
Sine.
Sine, right? Opposite of our hypotenuse. So we have sine of theta is opposite over hypotenuse. So here the theta angle is 45. And the opposite side is x, and the hypotenuse is 30. So how do we solve for x then? Well,
Isolate x, so it would be x equals sine of 45 times 30.
yeah, sine of 45 times 30. So basically multiply both sides by 30. Okay, are we solving for x? No, so unlike the problem we had yesterday, we're not actually solving for x. but at least we got somewhere. So we're tempted to put in our calculators this number, and we resist that temptation because this is just a number, right? 30 is just a number. Multiply sine of 45 just as a number. Let's look at the green triangle. What's the relationship that we have there? What's the relationship we have with the green triangle? Audrey? Good, right? Here we have 60. We have the opposite side. Here, A is our hypotenuse. Sorry?
What?
Oh, I thought somebody called my name.
No.
Okay. So here we got sine of theta is opposite over hypotenuse. So here, theta is 60. What's my opposite side? X. And what's my hypotenuse? A. Well, we're trying to solve for A, so you might think I want to isolate for A. But I'm not going to do that yet. I want to isolate for X. How do I isolate for X in this case? Sorry? I don't move things in math.
Right, so you multiply both sides by 8.
Good, we're going to multiply both sides by A. So we got A times the sine of 60 is equal to X. So now we have two equations, both something equal to X. X is equal to this, X is equal to that. So what can I apply? Yeah, I could do substitution. So here I'm going to have 30 times the sine of 45 is equal to A times the sine of 60. So we did something similar to that yesterday. We're doing that again today. But now we're actually solving, we can actually solve for A now. How can we solve for A? Kenna? Yeah, so we're going to divide both sides by sine of 60. So A is really sine of 30 times sine of 45 divided by the sine of 60. So A is, everybody got their calculators? So remember, please bring your calculators to math class. As I'm going through examples, type in where we're going so that you know you're doing the right thing in your calculator. We're all getting the same answer. So you got 30 times the sine of 45 divided by the sine of 60 is equal to roughly 24.49.
Should it always be 2 decimal places?
Sure, for now. Okay, is that kind of cool? Figure out A. Now, if I was to give this problem, yes, Jenny?
Why can't you just find the value of x and put that into the equation?
We could, and you could have done that, right? But we're still going to do a two-step process. I just kind of did it a little bit differently because we're going to show you something kind of cool now.
But
Right. That hopefully won't blow you out of the water like I did last class.
you ultimately come out with the same.
You come on the same, right? And this time I want to make it more concrete by actually putting numbers in here, so that I kind of see what we're doing. Actually get an answer. You guys are so desperate for an answer. I see that. It doesn't make sense to me until I actually see an answer. Now, if I gave you a bunch of questions like this, would you want to do this math all the time? How many wants to? Raise your hand.
I would prefer this over something more challenging.
Okay.
Yeah.
But if it could be easier,
That was easier.
would you choose to do this?
That was easier?
No, if something else was easier, would you still choose to do this? No. But unless we expand our thinking a little bit, this is exactly what we're going to do all the time if we don't understand something. So what I'm going to do is I'm going to abstract this out a little bit. And this is what I want you to do on your triangles. And so from now on, when we label our triangles, we're going to label them a certain way. Okay, we're going to label them with letters. Big letters, capital letters represent angles. The little letter is going to represent side lengths. And there's going to be an order. If you label a side length, a letter, the opposite angle to that will have the exact same letter. So here we got A already. The opposite angle to it, we'll get big A. Okay, so label your diagram the same way as I'm doing now. Now the other ones don't have anything, so I could arbitrarily choose. So I'm going to label that angle B. So I'm going to have a side length B. Where is that side length B?
30.
Yeah, it's going to be B where the 30 is. So really B is equal to 30. And finally, the last vertex, I'll label it C. The big C. So I have a big C, I need a little c. Where's that little c going to come from? Where's that little c? Which side is that? Well, there's only one side left. When it's opposite of it, it's the one that's on the bottom here. Okay? So if I was to label my triangle this way, this is what happens. Okay? Now I'm going to do something. I'm going to go back a little bit. I'm going to take what we did over here. Okay? You see from that triangle, we got that equation. It was true, right? I'm just going to plug the letters back in. So what was 30? What letter was that?
B.
B, small b, times the sine. Angle 45, what letter was that? Sorry?
Big A.
Big A is equal to A is still A. And finally, what's 60? Sorry? Capital B. Okay, so I don't know if you ever told this in grade 9. I think I told you once. I'm going to re-emphasize. We have an equation here. In math, you're allowed to do anything you want to an equation. Anything. 2 rules. If you do something on one side, you have to do it to the other. Right? So again, when we were doing things before, dividing both sides by sine of 60, we're allowed to do that, right? You just have to do it to both sides. And if you do it to the side, you have to do it to everything on that side. Right? Those are the 2 simple rules you must follow to keep your equations true. So you're going to do some little bit algebra magic here.
I thought there was no magic in that.
Algebra magic, there is no. I'm going to divide both sides by sine of A. Okay? Stay with me. Keep writing. If I divide both sides by the sine of A, what do I get? What do I get on the left side? I just get B. What do I get on the right side? Well, I still get A times the sine of B over sine of A. Well, now I'm going to choose, I'm going to multiply both sides by the sine of A. Why do I want that? I just feel like it. But you know what? What I'm seeing on this side, I don't like fractions. No, sorry. I don't want, I want to divide both sides by sine of B. Sorry. So I want to divide both sides by sine of B.
Not A.
Sorry, not A. I want to divide both sides by sine of B. So what am I left with on this side? B over sine of B. And what am I left with the right? Well, if I divide this side by sine of B, my sine of B's cancel out. So I get A over sine of A. So what we see here is we have this unique relationship between one side and the sine of the angle on the other. All those proportions are equal for A and B. And what will happen is we discover if we continue this, and I took this triangle and I made it like this and did the right angle, that same thing happens as well. you have this. What does this sort of look like? We did something in chapter 7 that looks similar to this. Similar triangles. We're dealing with proportions, right? So now we got something that looks very similar, although the concept is quite different, but the mechanisms are quite similar. And then we have a relationship between the angles and the opposite side. So what I want you to do on your paper is redraw our triangle. Okay, nice and big. It doesn't have to be that big. But now we're just going to remove the numbers and just leave our letters there. So you can label your triangle however way you like. I did it A, B, C, counterclockwise. What you want to do is you want to label your sides appropriately. Right? The side opposite your angle takes the lowercase. Okay, so the important concept behind today's lesson is this is called the sine law. And this is how it was sort of derived or proved. Right? Sine law is really little a over sine of big A is equal to little b over sine of big B is equal to little c over sine of big C. Pretty easy equation to remember. Another way you can write this, and I won't do the algebra to prove it, because I'm not proving it for today, is it can also be written as almost flipping everything. Sine of big A over little a is equal to sine of big B over little b is equal to sine of big C over little c. Those two things are the same. So you can use the sine law either way. The question in homework that will ask you why you think that is and why would you choose one over the other. Hopefully one of my examples will demonstrate that. If you were thinking that already. Okay, everybody go with this slide? So here's an example. We want to solve this triangle. So what's solving for a triangle mean again? Good. Find all the angles and sides. Determine all the side lengths and all the angles. So here we'll round each side to the nearest hundredth. How many decimal places is that? 2. And to every degree to the nearest 10. We're not talking about degrees here. That's the next question. So round each side length to the nearest 100. So where do you think we might want to start? Start again? Sure, let's label our triangle. So I'm going to choose this as A. So down here would be A is equal to that. Let's say this is B. So that will be B. And if this must make this C. So this side length here is C. Okay? The order doesn't matter. How you do it doesn't matter. As long as you keep the matching opposite side. Okay?
Doesn't matter which one's capital.
The angles are capital. The sides are lowercase. What's one other thing we kind of do on this one, kind of quickly. Hopefully you can see it. What's one thing that we kind of solve on here quickly? Marcus?
We could find the angle A.
Yeah, we could find angle A. How do we get angle A?
180 minus 83 minus 26.
And that is equal to 83 plus 26 is 109. 180 minus 89 is 71. Right? So once we see we have two angles of a triangle, we always get the third due to a 180 rule. So now we just need the side lengths. So I'm going to two right angle triangles? You guys all looking at me funny. Is that what I want to do? No, I don't want to do that now, right? I don't need to do that. I can use the sine law. So what's the sine law again? A over sine of A. Good. Right? Those who are musical could actually almost make a song out of that if you want. So A over sine of A, B over sine of B, C over sine of C. And we just start plugging in our numbers. Same thing sort of we did with our equivalent triangles, except this one is easier. The ratios, we know what they are right away. We don't have to match up angles and stuff like that. So here, what's A? A is 53. What's big A? Sorry, little a, right? Little a is 53. What's big A? 71. So we got sine of 71 is equal to, what's B? We don't know. What's sine of B? Or sorry, what's big B? Big B is 83. And do we know C? No. And then what's big C? It's 26. Okay, so here's our magic ratio. Right? That's the ratio where basically we know both the numerator and denominator, and then so we're going to solve both sides. So now it's just algebra after that. I'll do this, the B in red. So here, I'm looking at that. So I'm going to cross multiply. No, actually, I'm just going to multiply both sides by sine of 83. So 53 times the sine of 83 over sine of 71 is equal to B. So B is?
24.57.
You did it already?
Yeah.
What is it?
24.57.
24.57. If you have your calculators, you want to verify that?
Why did you only multiply the numerator by sine of 83? Like, what's...
Well, I multiply on both sides of the equal sign,
Oh,
right? So if I multiply sine of 83 on this side, I'm just left with B on the right hand
Never
side.
mind, never mind. It's actually 55.64.
Okay, I can't trust Adrian anymore.
I labeled it differently from you.
I'm going to take out my trusty calculator.
Okay.
Okay, everybody do the same thing. I mean, nobody caught Adrian.
I got myself.
So yeah, he shouldn't have to catch himself. He's got a network of support here. So 53 times the sine of 83 divided by sine of 71. So 55.64. Okay. C, we're going to do the same thing. So here I'm going to instead for C, we have 53 over sine of 71 is equal to C over sine of 26. So I'll multiply both sides by sine of 26. And then do that calculation. So 53 times the sine of 26 divided by the sine of 71 gives me 24.57. So C is equal to 24.57. B was 55.64. Okay. Questions? Right. So obviously here the algebra, we don't have to go through all that once we discover this principle. But I think honestly, the cool part was before. Discovering these principles, see why the sine law actually makes sense, why it actually works. So B is 55.64, C is 24.57, and angle A was 71 degrees. Those are only three things we use. Where?
Sure, A and B. There's two.
Sorry, where looking at?
The red blocks.
Here? Why? Here I basically multiply sine of A3 on both sides. I didn't cross multiply, right? And so once I multiply sine of A3 on this side, I'm just left with B because they cancel out, and the top part is sine of A3 plus 53. Any other questions? Not bad? Hopefully. So here's another question. Press pause now to solve the problem by yourself. Okay, so hopefully it came up with a triangle that looks something like this. Oh, it's okay. You guys, are you still solving it?
Go ahead.
Because I don't want to take it up now, so. Sorry, I was thinking. So I got sine length D, so this must be D. So this has to be E, and this has to be E. So I'm going to try to do this two ways, and hopefully you can see the difference between the two. As this question was intently done on this. So we'll start off with our sine law. So we got sine of, we didn't have that. We had D over sine of D is equal to E over sine of E is equal to F over sine of F. Okay, so we know our F's.
This was from that one.
Doesn't matter. Right? I just like to think in alphabetical order. Alright, so we got F is 42. Well, first of all, I don't know D. No, I do know little d. Little d is 64 over sine of, I don't know big D. I don't know little e, and I don't know big E. And then, but I do know F, and little f. So these are likely the ratios that you set up. So which was our magic ratio? This one, right? Because we both know the numerator and denominator, right? Or can I do anything with this one? No, both of them are unknown. So I'm really stuck with my first step. I have to do the D, sine of D. So I'm going to rewrite it out over here. 64 over sine of D is equal to 42 over sine of, thank you, 35. We're a little bit thrown off with sine D on the bottom. So basically we need to solve for D. So that's the tricky part here.
Is it just do sine of 64?
But let's work through the algebra on this first. No wonder I'm off. I moved this board. So what we could do is, if you guys haven't seen this before, you could cross multiply to get rid of our fractions. That's a shortcut to two algebraic truths. What we're doing is we're multiplying sine of 35 on both sides. So we're left with 42, and sine of 35 times 64. And multiplying sine of D on both sides. So that sine of D disappears here, and you get 42 times the sine of D. That's what cross multiplying really implies. So we got sine of 35 times 64 equal to 42 times the sine of D. So how can we isolate for D? So that's a little bit tricky part. So unlike when we remember we had x squared, we had a coefficient from the x squared, you couldn't take the square root of it right away. You had to divide by the coefficient. So we need to divide by the coefficient here first. I say you're right?
So you divide both sides by 42?
Yeah. So we get sine of D is equal to sine of 35 times 64 divided by 42 We can plug that into your calculators. What do you get?
0.8.
Sine of 35 times 64 divided by 42. 0.80? No.
I got it.
It's 0.87.
Sine of 35, I did close my bracket in the calculator, times 64 divided by 42. 0.874?
Yeah.
Sine of D. Is that not a question from Unit 7 test? How do we solve for D?
Inverse
Yeah.
that, inverse that.
So the key here is you need that sign of the letter all by itself first. You need to isolate for that. And now you can do the inverse sign of 0.874 is equal to D. So what's D?
60.
On some calculators that you have that leave an answer there, I think all you have to do is you just do an inverse sign of that answer that you have there. Shift inverse sign, and you get the answer of about 60.9.
Yeah.
Okay. So here we got angle D is 60.9. Was that pretty tough? Took long. Watch this. Remember, there are two ways of writing the sine ratio, right? What are we trying to solve for here? An angle or a side? No, on this first one. Are we solving for an angle or a side? Angle. We having troubles with yet another calculator?
Yeah. It says error when she does the.
Okay, Cecilia, can I help you with that afterwards? Okay, it's more important to focus on this right now. Okay? When we're solving for an angle, it is easier if you put your angle on top. So I'm going to do this on blue on the side here. So here I'm going to do sine of f over f is equal to sine of d over d. That is one of the ratios that we have. What's f?
42.
35? Sorry, big F is 35, little f is 42. Sine of d, d is, we don't know. Little d is 64. Now the algebra there is a little bit more clear because our unknowns on top, our unknowns on the numerator. So multiply both sides by 64. So we get sine of 35 over 42 is equal to d. So it took us a lot less steps to get to this point over here. That's where they're the same. Okay? So that's why there's two versions, or you can make use of the two versions depending on what you're solving for. Okay? So once we know d, 60.9, can we work with the other one?
Yeah.
Can we solve for e now? How? So once we got our other angle, we can figure out the other one. So what's 180 minus 35 minus 60.9?
84.1.
84.1? Okay. And I'm not going to take the time to go solving for little e because it's everything. So now we have the final ratio, and I'll do it under here, is actually Cecilia did this. I want to highlight it. Now that we know both big D and little d, can we use this as one of our known ratios?
Yes.
Yes? Right? We know little d and big D, but
Isn't it unreliable because if it's wrong, then you're even wrong as well.
yes. So if you got this wrong in all this algebra, which happens, right? Then you get it wrong the other answer is wrong, right? So stick with your known, which is this part, right? So we're gonna have F, which is 42 over sine of 35 is equal to E over sine of 60.9. Okay? So with this question, you had to work with a number that you calculated because there was two unknowns there. And then you solve for E. Yes, Adrian?
But if you get D wrong, wouldn't they E be wrong as well because you can't get the angle?
Yeah, it would, but at least I would be a little bit more forgiving because you were working with a known ratio, right? Because then you're gonna make me do more math to follow your wrong path, and I might be in a not good mood when I do that. Miss Kendra? Yeah, 42 over sine of 35 equals E over sine of 60.9. And then do the algebra, solve for E.
Say if while we're doing D, we do like a miscalculation and type something in wrong and we get the wrong answer, but we continue to solve it in the correct format using the wrong answer.
Using D, like I said, if I'm in a good mood, I might be a little more lenient. If 106 people do this before you, then I might just go back and say, everybody taking a half mark off. I don't know. Always stick with your known ratios. Okay? Use the numbers that you know for sure. Okay, any other questions on that?